Howdy folks. It's a little bit of an older video. I shot this one at the end of 2018, but it's a bit of a look into both the past and the future, because this is definitely where I'm going with the machine. As you get started here, you'll see it's going to home the x-axis here. We'll start there, and then it'll home the z-axis. The gibs are super loose here, so you should never see your carriage bouncing around like that. And then kind of the fun thing that we're testing here is doing synchronous movement between the spindle and the carriage. So one thing to keep in mind on these CNC lathes is that unlike on a manual lathe, there's no geared connection between the spindle and the lead screw. So that means that all of the coordinated movement has to be done in electronics and software. So this particular machine, I've crammed a NEMA 23 stepper motor in the back to drive the spindle, and hopefully soon be upgrading that to a NEMA 34 to get a little more power and control there. Let's see. So let's take a little detour into lathe axis geometry just to make sure we're talking about the same thing before I get to the next couple steps. You can see the carriage moving back and forth towards and away from the chuck there. That's the z-axis. And then at the beginning, when you saw the cross slide moving from this perspective, it looks like up and down. That's the x-axis. And then the rotating of the spindle itself is called the c-axis, as in ABC axis. If there were a third axis kind of coming out of the screen, that would be the y-axis. But most lathes don't do that. You get into really high-end equipment, you can get into stuff like that, but most things you'll see in a home shop aren't going to have anything like that. So, given those, that helps it make a lot more sense that this move that you're looking at is actually a straight line in the code. It's just a straight line move in the ZC plane, if that makes sense. So as the z-axis moves across the bed here, you'll see that the spindle is rotating at the approximate same speed to go the same distance. And so you get into really kind of fun math where you're talking about, a number of degrees or radians something needs to turn. At the same time, you're talking about millimeters or inches of how far something needs to go away. You can play around with it if you know the diameter of your stock, then you know the circumference, so you know kind of what the plane wrapped around the circumference of your stock looks like. So then you can think about the whole thing as moving in that plane that just happens to be wrapped around a cylinder. So, yeah, it's kind of fun stuff dealing with, kind of more advanced geometries here. So, this is just a really quick one for today. Just wanted to show you some of the stuff that I've been playing with here. And, yeah, it doesn't get much more interesting, so I'm going to speed the rest of the video up. And, yeah, next time we'll test it out cutting more than air. And we will see you all then. Cheers.